All right, so today we're going to do a lesson on tangents. And in mathematics, points of tangency, to dumb it down, is if you drew a line touching a circle, right? It's the point that touches a circle at exactly one point, yeah? So there exists one point where you could touch the circle where it doesn't touch at 2 points. Like this would touch at 2 points, right? And even that would touch at 2 points. Yeah? So it's the point that touches once. And what's important about it is it makes a right angle with the center. Okay? Now I will tell you sometimes, I'm not sure what, I'll have to show you an example of this as we go, but for some reason a lot of the time, maybe it's not here. Oh yeah, if this gets extended out, a lot of the time people mess up and think this is the right angle. So if this tangent line was farther and you're doing this, right? A lot of people mess up and call this the right angle. But the right angle is where it's touching the circle. If you get that stuck in your head, you'll make a lot less mistakes, okay? Now, when you deal with tangencies, you're going to end up with a right angle there. So when you start constructing things, what are you going to see a lot? Right triangles, which means what's going to pop up all the time? Pythagorean theorem, yeah? So you'll see a whole bunch of Pythagorean theorems in these, yeah? All right, so back to these notes here. That'll be a point of tangency, right? And that will be a right angle, yeah? Also, if I drew this one in, T would be a right angle, yeah? Got it? And there's some interesting things that happen when you do these. We'll get there. I think we'll get there in a few minutes. Yeah, we'll get there in a few minutes. All right, let's just focus on this first. Now listen, what they're going to like to do is hide radii from you. Okay? So if I'm looking at example 1, let's make sure we go through these first. A line is tangent to a circle if and only it's perpendicular to a radius at the point of tangency. That makes sense? It's a tangent if that point makes a right angle with the center, and if 2 segments from the exterior point are tangent to a circle, then they are congruent. If 2 segments from the same exterior point are tangent to the circle, they're congruent. Let's talk about that. What they're saying is, if you have a point out in space and you construct the tangents to the circle, yeah, those two would have to be equal. Okay? The math behind it's quite easy. If you construct this in, right, you got a right angle, right? Right angle, because that's what a tangent does, right? We don't know that these are equal yet, right? But what do we know? Radii are equal, and that's equal to itself, right? Right? And that's not angle side side, that's hypotenuse leg. Yeah? Because with a right angle, that's hypotenuse leg, which means these are equal, yeah? Which becomes important, because it's going to save you a lot of work sometimes. Yeah? So if you have a point that's tangent to the circle at 2 spots, then those distances have to be equal to each other. All right. Not going to help us here, but we're missing information. We're trying to figure out what x is. How long is AC? How long is AC? It's not 9, 17, because that's a radius and that's a radius. Yeah? So that whole length is 17. So you got an 8 something 17. Anybody know that one? 15 17. So x is 15, right? All right, let's do it again. Okay, so what do we know? Things that appear to be tangent are tangent, yeah? So those are both tangent points, right? So those are both right angles. So what's true about those segments? Nope. What's true about those segments? BC is equal to CD, right? So that means x plus 3 is equal to 7, so x is 4, yeah? Hard? No, stupid easy, right? Number 2. All right. Oh, yeah. Hey, make sure on 4 that in case I forget it, there's a nice way to do this problem. All right. What are we looking at here? J is a tangent, right? All right. So what do we got? We got the 15, 20 something. What's that a dilation of? Yeah, divide by 5, you get a 3, 4. That's a 3, 4, 5 dilated. By what? So what is this? 25. So x is 25. All right, next one. Okay, welcome to the world's easiest problem. What is it? 12. All right, this one I want to talk about. If you pay attention here, I'm going to save you a lot of extra work, okay? So what you would do at first glance is you would say, well, this is 15, right? So you would end up with a 15 x plus 15 36 triangle, yeah? And you would have a hard time figuring out what that might be. And there are some workarounds for it, but there's a better way, right? I want you to see if you actually try to start solving this, look what will happen. You get, don't copy this, plus x plus 15 squared equals 36 squared, right? What do you end up with? A quadratic. Every once in a while, you're going to have to deal with the quadratic, yeah? And you're getting close to the end of the book, so you're going to have to get good at quadratics again because you're about to go to Algebra 2, yeah? So you'd have to solve that quadratic, but there's a better way to do this problem. Instead of calling that x plus 15, just call it y. Now what would that do for you? And so now if you look at it, if you call it y, you're actually avoiding quadratics in the process. So if I call this y, now it's 15y 36. Yeah? What can those be divided by? 3, right? 5 what? 5 something 12, right? Oh, is that 12? Oh, that's going to be ugly. Okay. Well, sometimes they're ugly.
No, I think y is the highest.
Oh, good. Nice catch. No one said anything sooner. Thank you. Good job. All right. So, yeah, he's right. The 36 is here, right? Oh. Wow, nobody said anything. 36x plus 15, right? And I don't want to deal with that, so I'm just going to call that y. Do you see what that does for me now? That becomes a 5, 12 what? 13 dilated by 3, so that's 39. So y is 39, yeah? But that's not the question. What's x? Well, x plus 15 makes 39, right? The radius, 15, plus x makes 39, so it's really easy to figure out what x is. And see how you avoid the quadratic that way. Yeah? So what is this, 24? 24. So that's a nice time. Sometimes you can't get around it. All right? Yeah, I'll show you. Hopefully I'll have one like this in a minute. All right. All right, the next one's pretty easy, right? If this is 21, how long is it from yay or ya or I? 21. Yeah? Be careful here again, right? 21 squared plus x squared equals, what is that, 27? I would check that triple real quick. 21 something, 29, thank you. Oh, okay, so you probably don't know that Pythagorean triple. It's a very rare one. Wait. 21, is it 25, 29?
No, it's 20,
20, 21, 29, there you go. Most people don't know that one, yeah? So if you don't know it, call it x, right? Well, it is x, right? So x squared plus 21 squared equals 29 squared. And don't forget, you can always go back and do quadratic or Pythagorean theorem to solve these, right? So what is that? That's 441 equals 841. I was about to do 729. Right? So x squared is equal to 400, which is 20, right? But if you know the 20, 21, 29, would have been easier, yeah? All right, x is 20. Is that hard? No. All right, 6 is basically the same thing. All right, so here's the next one. We've done inscribed circles before, right? We've done that with, I think, incenter, if I'm not mistaken. Isn't incenter the circle in the middle? Or is that centroid? Come back in time. We've done this before, right? Where we inscribe it. Inscribe the polygon inside the circle. Yeah? All right. Now we're going to circumscribe it, right? So we're going to slap that around the edge of it. Yeah? And something, when you do that, it actually makes the problems very easy to do. Because let's look at this one right here. Focus in on this. That's a tangent point, right? And that's a tangent point, right? So that's a right angle, that's a right angle. So you see what you're looking at here? That's two tangents. Ignore all the rest of the picture and just look at that, right? I mean, really just focus in on, you got the circle, and you got this, and you got this. Aren't they starting from the same point? And they're both tangent? So what's that mean? They're equal. That means this is equal to this. Which then means, same thing down here, this is equal to this. Which then means this is equal to this. This is equal to this, yes? Got it? Same thing here, right? This is equal to this. In this, if it's regular, I'm sure you can prove that they're all equal, but that's not really what it's saying. These are equal, yeah? These are equal, and yada, 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 all the way around the picture. It makes the math easy, yeah? All right, so here we go. ABC is circumscribed about O, right? All right, so look here. Focus just on this for a minute. You see this right here? They're both tangent, right? So what do I know about BD and BE? They're both 6. What do I know about AF and AD? They're both 12. What do I know about FC and EC? They're both 8. What's the question? The perimeter. The perimeter would be what? Would be add up the sides. So what do we got? We got 18 plus 20 plus 14, right? 18. Isn't that 12 and 6? 18. Let's do math. This side, and this side, right? Am I right on my math? That's right. Get wrecked, noobs. All right, what is this? 52. Which one are you looking at? We're turning it into a side now. We're not finding the perimeter of the circle. We're finding the perimeter of the triangle, yeah? All right, next one. All right, they're asking you to find out what x is, right? Okay, I know that this is 10, right? Right there is 10. So what else is 10? That's 10. And then I'm done then. What's x? X is 10 plus 13. Math easy, 23. Yeah? Number 2. Oh, find the perimeter? So just work our way around. If that's 17, this is 17. If that's 13, that's 13. So the perimeter would be what? 30 plus 27 plus 23. That's 50. That's 80, right? 80. All right. I'm not going to find the rest of these perimeters. Maybe for the third one I will. But we know this is 18, right? If that's 18, then what's this other one then? 8, right? Which means x is 8. Which means this is 14. And you just work your way around, yeah? Okay, we found x. X is 8, right? And let's just do the perimeter. What are we at now? Let's just do this a little bit faster now. Let's see, what's that? 26 plus 22, I believe. Plus, what's that? 32? Plus 32. So what are we at? Perimeter's what? Say 80? 50, 60, 70. Oh, yeah, 80. Easy? Yeah, not hard at all. All right. This one down here, not going to be any harder. So far, they've all been regular, right? But if that's 2x and that's also 2x, so then what is x? X has to be 4, yeah? All right, well, we can work our way around, right? If that's 8, right? So that must be 8, so that must be 8, right? We don't know that this is regular, but they're assuming that it's regular. So this is 8 and 8. I don't think we know that that's regular. I think you could make a triangle where 3 of them are equal and one of them is not. I don't think. All right, well, we got a crash in the software, so we're back to this problem. We were on a 3, I believe, right? Yeah, we really don't know that those are all 8, but we'll just go with it, right? So that will be what? 64, right? The perimeter would be 64 because each side is 16. 16 times 4. Yeah. All right. I'm not going to do the perimeter for 4, but this would be 6, right? And this would be 4. So the side would be 10, and then you could find the perimeter by doing math. Yes. All right. Let's look at this one because it even works for irregular shapes. Yeah. Hey, that was rhetorical. Yes, that's 3. I so want to say your name right now so it can be in a video for the next 30 years. There'll be a generation of children who won't want to name their child. Like, I don't know why I don't want to name my child that. I just feel like it's going to set them behind in life. We'll just keep it quiet. But their name rhymes with hotter. All right, so that's 6, right? That's 6 because that's 6, right? All right, so X would be 8, right? And the perimeter would be, what is this? Oh, hey, be careful. There's a 1 here too, yes? I know it's really hard. Oh, there's a 1 here, actually. Yeah? All right, so what do we get? 4 plus 7 plus 8 plus 5? Everybody okay with that? Yeah, be very careful with small ones like that that you include that point, yeah? 11, 19, 24? All right. Last one. All right, if that's 4, then this is 4. If that's 8, then x plus 2 must equal 8, right? So x plus 2 must equal 8, so x is 6, easy. If that's 5, this is 5, and if that's 9, this is 9. Perimeter is easy, right? Perimeter is, what are we at? 14 plus, what is that, 13? Plus, what's the next one down there? 8 plus 4, 12. And 13? Another 13? Did I do that right? 26, 36, 40, 52? All right, 52. Not hard, right? All right. There you go. Just remember what tangencies are, right? And those special properties make them a lot easier. Okay. Good luck with this.